Hi, my name is John Looney, and welcome to OSFC 2020. I'm sure you're as disappointed as I am not to be here in person and having all those wonderful side chats we enjoyed last year. But thank you for making the best of it and taking the time to join us virtually. I should say straight away, though, I am not a firmware engineer. For the last 15 years, I've been a site reliability engineer, or a production engineer, as we call it in Facebook. This usually means I grease the wheels of large distributed systems quite far from the hardware. So I think I'll need to explain why I'm here first before I tell you how we're hoping to move our fleet to open systems firmware. When I started in Facebook production engineering, I joined the provisioning team. Our mission was to get operating systems onto servers. We have to put operating systems on every type of hardware you can imagine, from the very big to the very small. We noticed speed and, more importantly, reliability was impacted by poor firmware. Sometimes bugs, sometimes missing important features. Sometimes the firmware was just bad. As people involved in building firmware, you know it's one thing to build a firmware image to a detailed specification. It's quite another thing to get that image to pass comprehensive test suites before declaring it good to ship. And even then, firmware causes problems. Production engineers know that the real world is a scary place. We keep finding new assumptions that we never thought to write into a specification document, never mind a test document. Like, you should allow TFTP images more than 1 megabyte, or TFTP transfers shouldn't fail if someone is pinging the IP address at the same time. We found machines in our fleet that didn't DHCP for months at a time. They looked dead and then later just woke up and managed to successfully install. We found an implementation that never freed up flash space as you change settings. So eventually it would run out of space on the SPI flash, and as a workaround would just wipe everything and reboot when it ran out of space. We found different vendors have different ideas of what DHCP standard means. We have new firmware updates that magically no longer respected boot order settings. You can still pay $250,000 to a server manufacturer to find that their firmware doesn't support IPv6. I can tell you of 3 such companies. A coworker once wrote a 3,000-line Python script to parse the ironically named human interface infrastructure tables, just to work out what type of TPM chip was present and enable it if it wasn't already enabled. Our software stack is already complex enough. I don't need people making it worse. With coreboot, we just run ls dev tpm0 to test if TPM is enabled. I'm sure all UEFI implementations inherit from one upstream repo eventually, but there are so many recensions in UEFI, you have no idea what bugs you're going to get with any new version. It's very exciting. I'm a production engineer. We can do without exciting. So I had a plan, right? We could get this done in 12 months. We found out we already had blobs for our Broadwell DE-based switches, so we could just stick that blob onto a server, boot it, easy. No, it wouldn't be easy. It's a lot more complicated in the real world. So I came to this project thinking it was going to take about a year. At my first OCP conference during discussion on OSF, someone from Intel pointed out that moving it to EFI took the industry nearly a decade. We aren't just changing firmware on some machines. We need to change a whole ecosystem. So let's have a look at that ecosystem from the perspective of a hyperscaler. Well, my perspective, being inside one. Apologies in advance for this giant wall of boxes, but each box represents months or years of effort for a new server platform. Now, Facebook isn't crazy enough to try and do all of this on our own. We rely on many contracting companies, hardware vendors, ODMs, original design manufacturers, and dozens of internal teams to introduce a new platform. Most people are reluctant to make their schedules any riskier, their jobs any harder, by changing something just to make one production engineer's lives easier. We need to reduce their risk and make their jobs easier. So let's talk about the hardware sourcing part of the ecosystem. It's the first thing people think about when they think about open firmware. Like, what are the processors we're going to use? What boards are supported already? Can we increase that number? Now, we buy a lot of CPUs. You could imagine we would have a reasonable amount of pull with silicon vendors, right? I knew the benefits OSF would bring to my team's services. We already had deployed a huge fleet of machines, and I wanted to get coreboot onto them. I assumed we could say, I'd like, the silicon IP blobs tested, ready to go with coreboot, please. We'd be given a bill, maybe we'd haggle, pay it, and start to work. I discovered that by the time hardware hits the data center, the teams that designed the silicon and the teams that worked on the firmware have already been disbanded and moved on. They're probably now working on CPUs that won't see the light of day for 3 years. Test harnesses for those old processors made of the original customer reference boards are probably already falling apart 4 or 5 years after they were first commissioned. And getting time on these test clusters and capacity from QA teams for blob changes and long shipped silicon, it's going to be reserved for critical issues only. So let's face it, right? The time to negotiate for core boot support on a processor is before you pay for the product, not after. I learned the hard way that we wouldn't be able to do a retrofit. Core boot support really does need to be a base requirement of the platform early in the development process before a CPU is selected. So we don't buy individual components and make our own machines. We provide outline designs to ODMs who tweak those designs to make them easier to manufacture in their facilities. They build and deliver us full racks, not components, not servers. Ideally, we want to buy our firmware from the same people who deliver us fully working racks. And that way, if something goes sideways, we can ask them to fix the issue. Whether it's our hardware or firmware bug, it's their problem. We don't want to be firmware experts on every platform long term. This means whoever builds our hardware needs to be okay with core boot. And this is not a quick transition, right? Hardware builders, they're busy people. They have other customers. They have existing ways of working, tools, processes that have helped them deliver many iterations of solid products previously. Even if some of those features of those solid products did not spark joy in me personally. Now, as a production engineer, the way software is built in the hardware world confused the hell out of me when I tried to understand how it worked. People don't commonly share code or upstream code in case they break other people's work, right? You can't just push, realize something broke, and then roll it back. So it's not surprising that bugs fixed in one firmware implementation rarely made their way into the other implementations. We will build a better ecosystem than that, though. We now have this great code sharing system where JSON blob describes the 15-odd components of firmware, the core boot GitHub hash, various blobs and their hashes, uroot, Linux kernel. And if someone has an experimental fix, they can push it to their own repo, send us a JSON blob, like this one, that mentions their repo and commit hash, and we can build exactly what they're working on locally. This is very different than mailing around patches, zip files, binaries, Dropbox links. We always know what we're working with, and it makes it easier to replicate bugs discovered by others. I hope we can release the details of this in the very near future, and if there's interest, we could even open source the tooling we've built for our book build system. But the assumption is that everyone has their own build tools, and it shouldn't matter what your build system is. We want to agree on the build inputs. Now, introducing experienced firmware engineers used to proprietary environments to an open development process is exciting. It includes exposing them to new collaborative design, testing, and code review practices. We also insisted on upstream first, which means we don't consider a feature delivered until it's upstreamed, and only then will be imported into our own repo. We don't want to risk forks. We don't want to risk ODMs and other partners using their own code different to the one on coreboot.org. As a first step, we mentored our partners through some starter projects, asking them to add small functionality to core boot and uroot, and then slightly more complex features later on. Some of them were nervous at first, but with coaching, they quickly realized they could work faster than ever before. As time went on, they were fully bought into the OSF ethos of good solutions, well thought out, that can be built on later. But hardware engineers, they write very different code than software engineers. Now, Facebook and the OSF community is doing a really good job of helping them build the right way from day one in a really welcoming environment. We show them how to test their code, and a talk later on this week, we'll talk about how some of my team are building an open test framework to give everyone confidence that these changes aren't breaking other people's systems. This is crucial to enabling more contributions from the platform experts, who by definition have less expertise on OSF code bases than they do on their own platforms. Now, as I said earlier, a retrofit is hard, if not impossible, from a silicon vendor perspective. But also, if an ODM has shipped us 50,000 machines and we flash our experimental firmware on it, can they stand over it? Can they really support it? We might have already spent a year qualifying the platform and its firmware. We found most of this old firmware as bugs, so it's not clear that there'll be a huge amount of benefit from a retrofit, even if it is possible. You can assume that the team who qualified the current system for production are also very busy qualifying next year's platforms. So we believe to get a foothold with OSF, you have to do it as a new product is being introduced. Make OSF one more reason to upgrade. I'm sure many of you are very familiar with the hardware development process, so I'll talk about how this impacts the introduction of a new firmware ecosystem. When Facebook play around with the new technology, trying to assess if it's useful or not, we call it a hack. This might be done on a customer reference board from a silicon vendor or some other basic prototype. If the hack looks promising, we work with our ODM partners. We tape out a real design tailored for our needs. We verify it boots, run some basic tests. We usually find some small bugs or decide we need to make changes to how it's cooled, powered, or maybe mechanical changes. We might also work with engineering samples of various silicon, trying to find the sweet spot for our use case. This is EVT, engineering validation tests. If we're happy with the EVT systems, we'll order bug fixed hardware and do some at-scale benchmarking. This is DVT, right? Verifying the design is good. Tooling will be built. Maybe it needs new kernels or diagnosis tools to understand the new hardware. Once we can automate adding a new rack to our fleet and our production workloads run reasonably well in it, we're ready for PVT, production verification tests. This gives the tooling team some time to perfect their support for the platform, while the factory irons out all the wrinkles in the production process. And once they're happy with their yields, the hardware is ready to enter mass production. But nobody's going to order 50 or 100,000 servers in the hope that a new firmware ecosystem can deliver a working product. So the sensible thing is build both a UEFI and an OSF firmware image for the new system. And while a lot of prep can be done on the customer reference board we get from our silicon vendors, it's not until you get a real platform hardware that you can be sure the solution is going to work. Now, there's going to be a certain amount of tension between the two firmware development teams, right? While firmware is rarely in the critical path of a new product introduction, the open system firmware project, being new, might not get the same amount of resources and priority from your internal teams, from your ODMs, from the silicon vendor as UEFI. But that shouldn't matter, right? Because OSF is less work to complete than UEFI, right? So even if we don't get the same resources, it should still complete earlier. And in fact, in our experience, it's about twice as fast for complex security features to be implemented on core boot than UEFI. Now, the last questions are, when do we hold a bake-off? What does that bake-off look like? Well, our stakeholders must agree on success criteria before they commit, even those who see nothing but downsides from the introduction of a new firmware technology. Facebook did something similar years ago. A new switch had the option to use a vendor's BMC or try an alpha quality, almost functional OpenBMC. We took a chance, went with OpenBMC, and the bug fixes came in hard and fast for the first few weeks, but we never regretted the decision. That said, a BMC that crash restarts occasionally is very different than mainboard firmware that has stability issues. So, assume DVT is done. We won the bake-off with UEFI. We have an image that works well on a few racks of machines. We now have to give this image to the factory so they can install it, test the hardware with that image before shipping us the hardware. Part of PVT, production validation testing, would be making sure that the OSF image doesn't impact rack builds. Because factories care about very different things than we do. They don't care about the latest, greatest software features. They want to get working hardware out the door as soon as possible. To help them, Facebook provides our manufacturing partners with extensive test suites that they can run in their factories. These are whole rack tests, as this is the unit of delivery that we effectively care about. The factory wants firmware bundles they can apply to the whole rack, which will pass good hardware and will show up any issues with broken or marginal hardware. It's fine to use an image that's a few months old as long as it can be updated later by the data center techs or the automation systems as they're brought into the data center. This means we need to work with factories to provide them with an OS image that's stable, has no dependencies on our infrastructure, and looks as similar as possible to the images that we want to deploy later. We don't want a factory to ship us 100 racks of bad hardware that looks fine until it gets a firmware update. And we really don't want a firmware image that fails 1 in 50 good machines due to a firmware bug. That could hold up deliveries for weeks. Lastly, factory test racks tend not to be cutting-edge data centers. They may not even have IPv6. They may need to use TFTP boot rather than NetBoot over HTTPS, like production. They might have custom test suites that change UEFI settings in various ways. Our Linux boot images need to either mimic the UEFI behavior they're expecting, or we need to modify each factory's test suites. Now, assume the factory is eventually happy with the firmware image and they're going to ship us hundreds of racks. Over the next decade, we've built some pretty comprehensive tooling that manages the life cycle of the fleet. This requires teams to track metadata like asset tags, IP addresses, machine owners, data like state. Is it working? What's running on it? What should be running on it? Is it broken? And lastly, how it's configured. What flags does it have? What kernels should it have? What tweaks have we applied? We work with over a dozen internal teams who either depend on functional firmware to do their job or who we depend on to get our firmware tested and deployed. The repair teams need to be confident that their diagnostics and auto remediations that they've built up over the years are going to work the same or better with new firmware. We have whole classes of problem where we might try to fix it by resetting a server or groups of servers to clear firmware or hardware bugs that we've seen before. OSF may make these remediations obsolete, which would be great. We might cause increased or decreased part swaps as we find new issues that weren't spotted before or accidentally miss existing ones. And this might impact teams who track spares inventory. The teams who track whole assets will want to make sure that our firmware still allows them to compare the components that we detect on boot with what was ordered from the factory. We also have teams who deploy and manage firmware. OSF is going to be deployed with slightly different tooling. Attestation using TPM will certainly work differently on OSF than UEFI. Lastly, the teams who get operating systems onto machines, deploy kernels, and configuration already have many workarounds for various UEFI bugs and limitations. We need to make sure those workarounds don't result in failures until everything has been moved over to OSF and we live in a land of unicorns and rainbows. Now, we promise to all of these stakeholders that with OSF, we can find bugs quickly, fix bugs quickly, and have a high confidence that new releases are safe to deploy quickly. But these benefits aren't free. Like any nimble software organization, we have a continuous integration and testing system for firmware and the OS. It's just more complex than your average Ruby on Rails app. So we monitor nightly builds of firmware images for all our currently supported platforms, Broadwell, Skylake, Cooper Lake servers, as well as some Broadwell-based switches. This catches issues with our local build scripts, patches that we've applied to them, recently updated components. You'd be amazed how updating something to improve the latest, greatest platform breaks the old workhorse. Now, once we have images, we have to verify these images are functional. It's still a work in progress, but we want to flash a selection of hardware, do a simple reboot, netboot tests, and then run our internal unified BIOS test suite that was previously built by our sustaining teams to qualify OSF in the same way we currently qualify new UEFI images. Last year, we were burned by an innocuous change to memory tables, which suddenly caused all Broadwell DE machines to fail to emit anything on serial. We had 900 core boot pull requests to sift through to find the issue because we hadn't rebuilt those images in a month. Ouch. Let's not do that again. Now, every so often, we're going to cut a release candidate and test it more comprehensively than our nightly builds. For instance, on switches, we might run through the full ASIC test suite to ensure firmware changes haven't impacted network performance. We might do a 1,000 reboot test to find rare DIM initialization issues, and you'd be amazed how often that finds a real bug. Then we roll out updates to the production fleet. Now, no matter how well you test standalone systems, some issues are only discovered in the real world. This is where you find that your NIC chip vendor stashes configuration data in CMOS, and a CMOS reset bricks the machine. Or that the new firmware has differently formatted ACPI tables in the new version, which are read by some obscure tool you've never heard of, and you don't find out about it until someone asks why hundreds of machines have been accidentally marked as bad, sent to a human for troubleshooting. Part of canarying is getting good data. So we work with the hardware analytics teams to identify firmware tuples, like this version of motherboard, this version of NIC, this version of bridge IC, this version of BMC, these kind of tuples. We want to find the ones that are less reliable or less performant than others. And it's rarely one thing, right? A new release of motherboard firmware might only exhibit problems when it's paired with a specific NIC firmware version. Now, we already have great teams who have vast experience deploying every type of firmware that you find in modern servers. We need to fit into their world. We don't want to move OSF to require, or we don't want a move to OSF to require work on their part. They are busy enough dealing with the existing world, so we need to walk carefully and not break things. In many cases, tooling that has to support UEFI from many different vendors is going to be ornate, full of special cases. We need to be careful not to interfere with those special cases and their remediations. We have tens of thousands of lines of firmware upgrade automation code. It's insanely complex to verify a TPM chip is enabled on all platforms. While on Linux boot, we just run stat dev TPM 0, right? We need to slot that tiny change in without breaking anything. You can imagine, this is not typical hardware engineering work. It's not, right? It's production engineering, which is why I'm here. So I've covered a lot today. To kind of sum up, we do need to engage with suppliers early, get them to do as much work as possible with plenty of warning. Expect that it'll be expensive the first time as they have to build out new processes and competencies to support your needs, maybe even hire extra people. Engage with the people in your organization who care about new hardware. It's going to be a lot more people than you expect. You have to convince them that long-term OSF will speed up the introduction of new hardware. Engage with the factories, ODMs, or OEMs who are making your kit. Get them to test the hardware with your preferred firmware installed. Don't let them ship you UEFI, or you might find hardware and firmware issues when your production environment flashes OSF the first time. Engage with the teams who run your production environment. Make sure they know to expect benefits. They should be the ones who most vocally support you. And if they don't, there's something wrong. Lastly, tell the world about what you're doing. Encourage them to follow you. The only way we're going to significantly improve firmware on servers and switches is to make UEFI or OSF as reasonable a question as Windows or Linux. We went through this 20 years ago, and Linux won. We can do it again. Thank you.